Hello everyone, welcome to my online lecture, Computer Aided Measurement and Control, MATLAB Simulink, and we want to program Arduino and simulate the especially servo and DC motor using MATLAB Simulink programming on the Arduino. Okay, and this one is our final lecture for this class, Computer Aided Measurement and Control. Okay, and we want to repeat the study DC motor and servo motor, but in today we are going to study in MATLAB Simulink. The objective of this study is, of course, we want to deal with the DC and servo motor in MATLAB Simulink, especially programming Arduino Uno. Of course, the devices you have to require in this class is Arduino Uno and micro DC motor, this kind of device, micro DC motor 3 volts, and micro servo motor 4.8 volts. SG, the type is SG90, which has the capability, the rotation. This one is not continuous servo motor. This one is the capability, the rotation is between 0 to 180 degree. And maybe you also need potentiometer or variable resistor. Okay, this kind of device. Okay. So I go to the introduction again. What is MATLAB Simulink? Okay, actually you already know, right? MATLAB Simulink is graphical programming method, which is we can call it this one drag and drop user interface for creating a simple or complex model, especially this kind of MATLAB Simulink for signal processing or control system or dynamic simulation. The purpose of MATLAB Simulink is basically to simulate a model or simulate a system, kind of system. Okay, in Simulink and MATLAB Simulink is basically integrated with MATLAB data and can be easily transferred between of this kind of program. So in this lecture, this online lecture, we want to study especially DC and servo motor control using MATLAB Simulink in Arduino Uno. Okay. So I just remind you about servo motor. Okay, which basically the servo motor. This kind of we use this kind of type SG90. Okay, it has the orange, red, and brown pin. I mean, this kind of cable, or pin we call it, and this orange cable is controlled by the pulse width modulation around frequency 50 Hz, and this kind of period, and the duty cycle is controlled within range this kind of period. I mean the width of signal, width of duty cycle. And this is a general definition of servo motor. Okay, which is the electromechanical devices, and it can rotate precisely, but in this gear motor I can't guarantee the precise of rotation. Anyway, if you have a better motor, you can this statement actually is correct for rotation and precise degree of rotation. And the motor servo in general basically is consists of this one, DC or AC motor. Okay, and it also has a gear mechanism to rotate the shaft, and it has also feedback devices or feedback device and electronic circuit. Okay, and this one is in general basically servo motor is a feedback control mechanism. It has a usually it has a controller inside, and there is a motor, DC or AC motor, and it consists of a gear mechanism on it to increase the torque. And for the sensor for feedback system, it's usually for in this plastic gear motor, the feedback system usually potentiometer. Okay, because it's cheap, and maybe some kind of motor, servo motor has a rotary encoder for feedback or for sense the position of the shaft. Okay, that is the basic of servo motor for definition. And I also want to remind you this how we rotate the degree of the shaft precisely when the first figure and the left figure we control using duty cycle percentage, the width of duty cycle. And maybe you can drive a 3% or 4% or 5% duty cycle and so on, 12% duty cycle, which is the equally similar with the degree of angle of the rotation of the shaft by control the input, the pulse width modulation. And it is a very basic, and this kind of period, this kind of motor has input period for 50 Hz or 20 millisecond period, and duty cycle is arranged within 600 to 2400 microsecond. Okay, this kind of if you example observe from oscilloscope, you can see basically when this rotation of shaft degree 0 degree, when you input 600 microsecond duty cycle period, width of pulse 600 microsecond, and for 180 degree you give the pulse signal with this one, this pulse signal not period, this one is a duty cycle with about 2400 microsecond. Okay, is it clear, right? I just remind you, maybe you forgot. Okay, let's begin for MATLAB Simulink. For simple program we will study in this lecture is for very basic servo motor, very basic connection, which is the orange is for control the input signal pulse width modulation. Pin 9 we connected into Arduino. Okay, for the center it is red cable is connected to the 5 volt, and the ground is black cable. Alright, it's very simple. Okay, if you open the MATLAB Simulink, I assume you already installed MATLAB and you already installed the Surface software add-on. For Arduino hardware for support package. for Arduino hardware. And you can see the block diagram here. We have a kind of standard servo, right? We will use this diagram block for today's lecture. And this can also has continuous servo right in here, but our motor is not continuous servo, so we don't use this block diagram. And this also has standard servo read. Maybe you can learn this block diagram by yourself. I don't teach you about this one. Okay, I just teach you how to use this function. Okay, for start this simulation, just drag and drop in here. For if you already open a blank Simulink, you have a kind of blank user interface in here. You just drag and drop in this, or just right click and you can put in. Anyway, if you open and double click this icon, you have kind of this statement in here from MATLAB. Arduino standard servo write and set position of the standard servo motor. The value is expected range of input is between 0 and 180. The value of 0 position is set at 0 degrees. Okay. The value of 180 position set at 180 degrees. Okay. So basically we just giving input with this range for standard servo motor between 0 and 180 degrees. Okay, and this also gives the pin, output pin, and I recommend you using a pulse width modulation pin. And Arduino, in Arduino we have this kind of pin, which is timer 0, 5, 6, and timer 1, 9, 10, and timer 3, timer 2, timer 0, timer 1, and timer 2, if I'm not wrong. Okay, so I will next. Okay, we go to experiment 1. For experiment 1, we just drive servo motor using pulse generator. You already know this one, right? Pulse generator. And in this pulse generator, we just giving the input, the two kind of input, that's 0 and 180 degree angle. In this case, I give the input sample time 0.1 and period about 20 number of sample. So basically the time is the very simple pulse generator. Okay, basically the minimum is 0 angle, maximum is 180 degree in here. If you see, okay, and the period is 2 seconds, because this one just assume you already know 0.1 multiply 20 sample. Okay, and this with pulse duty cycle in here about 1 second. So we just give the motor moving 180 degree and then changing 0 degree 1 second, and then 1 second 180 degree, 1 second 0 degree. Very simple, right? And you just have this kind of block. standard servo write. We already discussed in previous one using this one, standard servo write. Okay, drag and drop over there. Okay, you have it this, and you set this one is pin 9. Okay, as we agree in here, is pin 9 is connected in previous figure in here. We agree we use pin 9. Okay. Okay, for the scope, this one is scope. We use a scope and also display in here. And display we don't do anything. And for scope we have to sign kind of setting. For display, for of course for display, for comfortable investigation, I don't know the English name, just observation, maybe observation the signal. And the first main in here, main tab, you click in here, open at start simulation. Maybe you need this one. If you check this one, the scope will automatically start when you start off the simulation. And in this case, we use the sample time 0.1 second. Okay, and you click the time tab in here, and you use the scroll type in here, and maybe you check this metric based on time span in here for time units. Okay, and you can check this one, show time axis label. Okay, for next display tab in here, you can set this one 0 and 180 degree for maximum, for minimum 0, or whatever you want to set in here. It doesn't matter, it depends on you. And y label is angle. As we can see in here, the label for y-axis is angle. If you set angle, it will appear in here angle. Okay, if you check this one, you can see in here will show the time in here. Okay, okay, for begin the simulation, before begin simulation, you have to set kind of setting, and you have to go tools in here and go to run or to target hardware and prepare to run, and it will has some kind of configuration. And in hardware configuration, you have to set your Arduino Uno as usual, and you can set you can set this host board connection, and you can set this one automatically, or you can set this one manually, and you have to check and you have to know which COM port you connected for Arduino Uno. Okay, and you have to set in this time. Maybe you can use the ANF, means that infinite. Okay, so it will go simulation, it will run simulation continuously. Okay, you have to set this also external for Arduino Uno, not internal. Select external. Okay, and then after that you can make sure everything is infinite and external. After make sure the infinite external, you can run this type of icon. You just click this one. Okay, this one is a video when recorded the Pose signal between 0, only move 0 and 180 degree. Okay, the shaft is rotate based on position 0 degree and 180 degree based on command for here. And you can see in here the display, the only show the 0 and 180 degree. Okay. Okay, I will show you this one for how to stop this one. Okay, I will skip this one, and we can already set on my desktop this one, servo motor, but also potentiometer in here. But later we will discuss this potentiometer, driving servo motor, and you already open MATLAB in here. I use 2018 version, 2018B. So for blank model, you just go through the common standard servo right. Okay, can drag and drop or add block to model, and you need some kind of scope. Sorry, what happened with this? Hello. Very weird. Okay, so just scope in here. Another is we have some kind of where is the forgive me, I forgot where is the sync. Yeah, I sync. I am looking for display, and I'm looking for push generator. Is it in here in sources? Okay, you can close it, this one. Okay, you can set arrangement in here. You can set the pin. Okay, we use pin 9, and push generator we set in here for period 20, push period delay. We use 0.1, so everything is between 1 push width 1 second, and period is 2 second period. Okay. Okay, just connect it this one and go to scope, double click the block diagram. If you want to show the name, you can go to display and set this one. Hide automatic names is unchecked, this one. You can see the name of this diagram, each block diagrams. Okay, and you set this one 0 point. Same with this push generator. At the time you have to scroll, and maybe this one can apply, and display you can set this one, and the label is angle, of course. Okay. Maybe can do more smaller. Okay, before that you have to go setting, or you can go tools and prepare to run, or you go to this icon, similar. In this, go to hardware implementation, and you have to select the Arduino of your Arduino. In my case, we use Arduino. Set target hardware resources and host board connection. Maybe I will set it manually in here. In my case, the COM5, I can check in here for device manager. See, this one USB serial device COM5. Okay, I'm sure this one is COM5. You can apply and OK, and you can set this one infinite. You can go to external. Okay, don't forget. Okay, you can run this one. Oh, sorry, this one save. Okay, whatever, I can name it test lecture 14. Can save it. And I begin to run. Maybe it takes time. So in here, we'll set some kind of figure in here. I think this one is not necessary. I think this one can more bigger. Oops. Okay. I don't know. My computer is not very fast. It's still building. And as we can see in here, I don't speak anything in here, so it's still building. Okay, now I think start. This is code generator. Can close it. Okay, now motor working. It's on the signal from here. Okay, you can see also in here display is real time 180 degree. Okay, as we can see, now the motor is rotate according to the value from here from force generator. You can see from the display in here 0 and 180 degree of angle. 0 and 180 degree rotation. Each for period 2 seconds and pulse width 1 second. Okay, just simply rotation like this. Okay, As you can see in here, the time period is similar. Okay. Okay, for next experiment. Okay, this one is a video again. I just repeat from here. Okay, for next experiment, you can see in here we just replace the first generator with the repeating sequence signal. We can put the value in here. This one is like a ramp signal. For ramp signal, we just give the value of time in here: 0, 1 second, 2 second, 3 second, 4 second, up to 9 second. And the output value, we just give the value, the angle in here. Okay, just do this experiment. I think this one is we just replace the first generator with the ramp signal, or we call it this one repeating sequence, whatever. Okay, this one the source, and maybe you can connect this one, and you're just giving the value for each 20 degree, 40, something like this. And for 1, 2, 3, up to 9 second. Okay, just apply. I don't change any setting, another setting, just close this library, and I think we can see the how the servo motor rotates, and I think we just click a run in here. This MATLAB is slightly low. Low. It's not fast uploading the code. Maybe it's very large code inside. So during building, I think it takes about around 5 minutes, I think. So in here, I just keep silence. Okay, code generation is appear. And now the motor is rotate based on the signal ramp in here, as you can see. You can see the display of angle in here up to 170 around. It's not the maximum 180, I think, in here. You can see. Okay, it's increased the angle from 0 linearly until 180 and start again from 0 to up to 180 degree is ramp signal. Okay, I think it's very easy for you to practice at home in this kind of diagram block. Okay, I think I will stop this simulation and stop this button. Okay, let's go back to presentation. Okay, this kind of scope setting, I think similar from previous setting. There is no change in here because it's similar. And this one, I don't change this one. And you, of course, you have to select infinite time if you want to run continuously forever. You have to set infinite and external device and set run. And this one is a video I have done before. The rotation angle follows the input signal from this ramp signal linearly increase from 0 to 180 degree. Okay, think we can next. Okay, for next experiment 3, you can see in here we just replace the using sine wave function. In the sine wave function, you can see the equation, which is amplitude multiplies sine frequency multiple times plus phase and plus bias. So in order to varies from 0 to 180 degrees, so we need the bias. So this one is sinusoidal, so we have to start in here. This one is 180 degree maximum, right? And this one is 0, so we need bias in here 90 degree and amplitude 90 degree. Okay, so this one is 90 degree, so this one also 90 degree. Sorry, it's very difficult to write using mouse. And in here we just set the frequency around 1 radian per second, and there is no phase in here, and we use sampling time 0.01. So if you go back to Simulink, we just basically change this repeating sequence with the sine wave in here. Sorry, I am correct, this one sine wave. I think yes, looks different. Time based, we use time based in here, and we set the 90 degree frequency 1. We use a sample time 0.01. I just save this one. All right, and I think everything is remain the same. For hardware configuration, already we set in here Arduino Uno and host we set manually in this case. Close library, and maybe we can see the what happens for next experiment. So in here we just set external, of course infinite, and I think just click run. We don't define same in for scope. I think we have to set the scope similar for sine wave. Yeah, in here 0.01 for scope. We have to set basically the same with the sine generator. Okay, I think just apply in here. Okay, we run again. We have to wait and up to 5 minutes maybe. I don't know. I wish there is no error in this experiment. I wish there is no error and there is no failure of the motor. Okay. All right. Now for the generation appear, can close that. I think it will success. Okay, now motor moving based on the value from the sinusoidal function. In here, okay, I think this experiment is very easy for you to do at home. Just simple set the sign generator in here and scope and display also, and just go through the pin 9 for pulse width modulation for servo motor. In this case, we drive the servo motor using sinusoidal wave from degree 0 to 180 degree angle. And you can see in here, when reach the peak, the motor is slow and increase the speed. Anyway, I will stop this experiment. Okay, and I can go back to PPT presentation slide, and for next setting, okay, this one setting is remain the same. Okay, and this one is video for this experiment which I have done in my laboratory, and in this case there is nothing special, and it's the same with our experiment today. And this one, the motor rotates based on the angle input from sinusoidal motion of the sine wave. Sinusoidal motion. Anyway, we can go to next experiment. Okay, for next experiment, we replace this function generator, whatever that one, square wave. We already do. Sorry, I want to draw something in here. We already did square wave in here, right? First experiment. For second experiment is ramp wave like this. Okay. And third experiment is sinusoidal wave like this. Okay. And that one is very straightforward. Now we just change this input to servo motor by constant value for constant variable, and we can name it as angle in here, and this one is driven by knob the dashboard. You can set in from dashboard, I call it that one. And in here we set the signal attributes as the unsigned integer 8, means the unsigned integer 8 bits. I think I'm not wrong. Correct me if I'm wrong. This one. And yeah, just change this function using, we want to basically giving the input using this variation of knob from 0 to 180 degree. And for connection, you have to connect this knob to the constant angle in here. Select constant angle and you can connect with the angle value in here. And for knob setting, you have to set the minimum and maximum value in here. Set minimum 0 angle and maximum 180 degree. Okay, very easy. Maybe this one is for scope setting. The sample time, we don't change it, 0.01. Previously we set 0.01, right? I remember. So everything doesn't change in here. Angle same, everything. This one is a kind of value when we rotate the knob. And for run target, prepare to run, I think it doesn't change, but in here, if you create a new file, you have to set again this one. Okay. And if you create from new blank, from this one, from new blank, you have to set again this one, infinite and external, and then click run. Okay. And this one is video. When we rotate the knob, and the motor response follows the angle input from this knob, and we just change it and rotate like this, and motor moving based on the angle input from knob. Okay, I think this one is can replace by potentiometer, which we will discuss later. This one, I think we have to do now for our experiment. Now in here we have sine wave previously, right? So we have to change this sine wave with a constant. So we have to look the constant in here. Remember the data type we have to change, I guess so. Okay, constant, just set value 0 in previous PPT. In PPT, I told you I used the unsigned integer 8 in here. There are a lot of data type for MATLAB. You can use double, single, or integer. But for not, I use the for integer number. So I just use integer number in here. Okay. And you have to set knob and look at the dashboard in here. Set the dashboard. This one, knob, there is knob. And add model to test lecture 14. Okay, we have a knob diagram block in here. You can click space to fit the space. You can close this one. And of course, you have to connect this one with this one. Select this constant, and there is option in there. Connect this one. Connect to constant value, or you can name it this one as angle. Sorry, I just make sure this one already connected. Okay. And see the connect this one angle constant. Type is linear, minimum, maximum, 180 degree. And the level you can see maybe the bottom. See the bottom is in the bottom there is angle value here. I think just like that. You can go setting in here. And hardware implementation, I set this one manually, okay, and set this one external, infinite, okay. I think everything is okay. Did I close the scope? So in here we can see, and okay, just run, click run in here. We have to wait. If there is no error and smooth the building compiler, we just waiting basically. Okay. Okay, now code generation is appear. It will run for a few seconds. Okay, now position is 0. When I rotate this one, the servo motor will rotate. Right? Can you see it? Now the angle position is 60 degree, 70, 80, maybe 90 in here. It's not precise, but can see the position of the shaft of the motor. So this one is 180 degree. Maybe I go back here. You can rotate this one whatever you want. There's not, as you give the value input. Basically this one is 80 and 90 degree is something like a error in here. Can you see it? But I cannot expect this gear motor. I think is not precise correctly in here. Okay, so this one is 0. Just simply like that. Okay, that one is the MATLAB Simulink. Control the motor servo using knob. Okay. Okay, I will stop this simulation. Okay, that is very easy to do this experiment. So next experiment, we have to drive using potentiometer. I guess so. If you want to watch this video again, I will show you this one using knob. This one you can rotate, and the motor responds based on the input you giving from knob. Okay, I will more faster here. Okay, and next slide. Okay, now we are going to using potentiometer. Finally, we use potentiometer, and I just want to remind you for connection for potentiometer. Some of students maybe still connect wrong, so remember in here, remember this kind of breadboard, this kind of 5 point in here is connect each other. This one is not connect like this one is disconnect in here. So basically this one connect, this one is connect, but this one is not connect through all like this, not like this way. So some student still put potentiometer in this side and cable in this side. So of course they think potentiometer is broken, but I think this is a wrong connection. So I just remind you in here and see clearly this connection line. This one is connected from here to here for power supply. Okay, deal? No question, right? For here, this one is connect each other for 5 point, but not connect to here. This one another side. Okay, so this one connect like this way, not like this way, but like this way. Okay. Okay, so is it clear? Okay, so I attach this figure. Can you see it? The potentiometer is side from this side, only this region. Okay, only for this region. Okay. Okay. Okay, we use this in here. Potentiometer is analog 0, and you of course need the 5 volts for potentiometer and also ground in here. And for pulse width modulation for servo motor, you connect to servo pin 9. Okay, is it clear? Okay. Okay, this one servo SG90 series, and orange to pin 9, VCC pin 5 volts, ground to ground. Okay, Arduino Uno. For analog 0 is potentiometer. Okay. Okay. Okay, so let's go to MATLAB Simulink for servo motor. We need the diagram block for analog input in here, of course, and set the pin 0 in here. Okay, pin 0 for a 0 pin, and sample time you set the 0.01 second. And here we use this one for smooth rotation, of course. And we need also gain in here, and to convert degree of angle to from decimal. You know, analog input is from 0 to 1000, 23 decimal number, because this one is 10 bits. Agree? Okay. Convert for angle 0 to 180. In here I use the data type of single. In here for precision, you can use also double, whatever. It depends on you. I use a single in here. And what else? Nothing. And for scope setting is remain the same. I just change this one -1 in here. Okay, let's do this setting. Now let's go back to Simulink. I think this one is clear for you. We can delete this one. Okay, let's go to library and we go to the command. So go to analog input. Okay, I want to reduce this view. Analog input. Sample time is similar with the scope. Analog 0. We deal with the analog 0, and maybe you can use this again here to conversion from decimal to angle. And in here I use just single. Whatever, it depends on you. You can use unsigned integer 8 or 16, as depends on you. And check the scope setting. Time is remain the same. And display I use in here -1 for see the 0 signal. Okay, I can close this library. Check again, this one, okay. Check again, this one, okay. I just save it. As you can see, I already installed potentiometer in my desk in here. See the cable in here, only this kind of side connect in here, don't connect on another side in this. Okay, it doesn't connect, of course. You have to connect in this side. Okay, I think for setting, remember okay, set manually and infinite external. Okay, remember, because it doesn't change, because already we set in here. We just modify this source of input, and I think we can run it. I wish there is no warning. Basically we are waiting in here, so I will not speak. We are waiting until code generation is appear. I install code generation basically, so it will give your option. But in here we are waiting. Okay, now servo motor open, code generation report appear. I just close it. Okay, now the value of the potentiometer are about in here. Can you see it? About 1196. So we can rotate this one. Can you see it? I rotate this one. Oh, it doesn't follow the command. What's wrong? Very interesting. So, something happened. This motor doesn't rotate. Oh, I don't face this problem before. I think this experiment is failed. I don't know what's happened. Maybe this data type is wrong. Maybe we can test again. And don't forget this one is, sorry. In diagnostics, maybe data validity, we can set this none. Did I put correctly pin number? There is the number of data in here. Scope display. Okay. Okay. Let's wish me luck. I wish it will run properly. Okay, we have value in here. Does the motor will rotate? Oh, motor doesn't rotate. That's very interesting. Oh, now it's rotate. Something problem with this motor? Now this motor is not broken. But as you can see, this one high success. Rotate motor using potentiometer. Can you see it? The motor follows the command of the potentiometer in here. Let's set this one as 0. And I want to see what's different with data type. Previously we used this one. I want to see, should be normal. Try to run again. Basically we are waiting. Yes, motor is rotate basically. Rotate over there. Okay. Okay, now it's rotate 0 position. It should be rotate this now. You can see the motor rotate now. Yes, I want. Okay. Okay, now it's rotate based on the input from the potentiometer. It should be like this. Can you see it? Okay. I rotate potentiometer basically, and the servo motor follows command from the analog input. Zero angle, 90 degree maybe, 180 degree. I really don't know what's problem from previous. Okay, so now it's success. Sometimes MATLAB is very awkward. Okay, so we can stop it this. So this one is our final experiment for servo motor. Okay, for next experiment we will, I think I will skip this one. Okay, don't forget to maybe check this data validity. Maybe there is precision loss. Maybe this one I missing previously, so it doesn't work. Anyway, just set infinite and external and click run. Okay, this one is perfect video, which you rotate this one. Should be the motor follows the command from the potentiometer. Okay. Okay, now you already learned this one. So I think this kind of simple project is similar like your final project, which is driving using potentiometer, driving servo motor. Driving servo motor using potentiometer. Okay. Okay, now we are going to talk about the DC motor. In here, remember, this one is just a reminder for you, the principle of DC motor. For DC motor, basically, there is the commutator and brush in here for connection, and this one is, we call it armature, or this one is a kind of wire. When the wire is, there is a current here, and there is also magnetic field in here from north to south. This one, magnetic field, and there is the produce the Laplace force in here. Am I correct? or Lorentz force in microscopic scale, for Laplace force for this for wire. Okay, and this one will rotate continuously because this one will change. In here there is separator in here. It will remain the same of the current. Okay, current flow in here goes like this. Okay, and this one is a reminder for you, and this animation is I just took from this website, from this great lecture for motor control. You can refer for here. And this one, if you open from DC motor, you can see the basically the, I don't know, this one is called it the windings, rotor and windings completely, and there is commutator in here, and if there is brushes in here, brushes. Okay, okay. Okay, to control the DC motor, we need some kind of edge bridge. In your Arduino kit, there is a edge bridge. We call it dual edge bridge. Name is L293D. Okay, you already know this one, right? This one is in homework 7, I think. So basically, this one is there is enable, which is goes with modulation, enable. In this side also same, and this one is power source for the motor DC. Its range is between around 4.5 volts to 36 volts for motor. And this one is there is kind of PNP transistor in here and NPN transistor in here. So basically we just change the direction of current flow from this side or this side, so the motor can drive or rotates counterclockwise or clockwise or counterclockwise. Okay, this is a connection from this pin. As you can see, this pin 1 is enable, pin 2 is input, which is the input for control the direction, input 1, and output is motor output 1. I think this one can put the positive side of motor anyway. And for pin 4 is ground, pin 5 is also ground. This is equally same, and the output 2 is motor output. For you can see it in here in output 1, and also there is output 2. You can connect this one either positive or negative for motor, both are, it doesn't matter. And there is input 2, this one is input 2, and this illustration is a switch in here. You set the direction of the motor, either 0 or 1 in here. Okay, and this one is source voltage motor, this one from 4.5 until 36 meter, if I'm not wrong. Okay, okay, basically this one is illustration when motor clockwise rotation. This one is analogy, when the input 1 is on, it means it's connected ground directly, and this one giving the signal as 0 in here. At the low state in here, the transistor will active in this side. This one is not active, so this one will go through here, the current will go through here, so motor will rotate clockwise, absolutely. And in this side, input are off, it means open. This one is high state. When the high state, this one is active. This one is not active. Okay, basically this current flow is just go through here, so motor is able to rotate clockwise. The clockwise and counterclockwise is basically just change the input and input 1 and input 2 reverse. So this one off, this one on, means then this one in low state in here. When a low state, this one is not active, this one is active. When it's active, this one is current flow go through here. Okay, this one is open. When open, this one is state is high. When the state is high, this one is active, this is not active. So basically this one is go through here. So that one is a basic principle. I guess I wish you understand my explanation. Okay, let's begin for experiment 6. I just do only one experiment for DC motor in here, because basically DC motor is just continuously rotate, or you just change the direction, or you just control the rotation, speed rotation for DC motor. For DC motor control, you just control the speed, number 1, that's using pulse width modulation, and number 2, control just direction. Okay, direction is clockwise or counterclockwise. Okay, is it clear? Okay, this one is a wiring schematic. So you just have Arduino, connect directly to driver motor, this L293D. Remember, this one connection pin in here, put in the middle of the breadboard. I don't put in this side. Okay, put in the middle, because it's a separate circuit. This one is separate circuit. Okay, you have need a jumper. So okay, this one is separate in here, you connect in middle. Okay, basically pulse width modulation, we use pin 9 as same like our study servo motor. And for input 1, pin 5, input 2, pin 6. Okay, so basically this one pin 5 and pin 4 and pin 5 is a ground. Okay, and this one is output to motor, either is plus or negative. You just put motor in this, and maybe you need the source in here for IC and for the motor. Connect to 3.3 volt for motor, because this one basically DC motor 3 volts. Okay, this one is a diagram block for this experiment. To control the speed, I used in here the slider block in here. Slider, you can find it from dashboard. This slider. The slider needs a constant. I call the name is a PWM value, whatever. And this one, there is a scope in here, and display of course. And we just need the constant in here for clockwise, counterclockwise, and we need the switch in here. And for clockwise, we just set this is 0, and counterclockwise, we just constant 1. So when this changing the switch in here, either 1 or 0. Okay, for clockwise we have to set this one. Pin input 1 is 1. Okay, means what? What is 1? What is 1? 1 is active, the digital output signal. It means high. Okay, should be high, and this one should be 0. So it will rotate, in this case, counterclockwise. Okay, you remember this one? This one is not logic, so it just convert 1 to 0 or 0 to 1. Okay. Okay, there is nothing special in here. I think we can go next. Just a slider connection. You just connect to variable pulse width modulation constant in here. I set constant in here. We have constant, and set the minimum 0 and 255 in here. Okay, for data type, I use this one, unsigned integer 8 in here. Okay. For scope, we have to change the value as the pulse width modulation in here. Sample time is, I think, remain the same from previous lecture. I mean, not previous lecture, previous experiment. So what should we do in here? In here we have to remove this one. Okay, you have to add the slider. Where is slider? This one. Maybe this one. You have to set from 0 to 55. And of course, you need a constant to support this value. And this value is, we just set the 0 and signal attribute, maybe unsigned integer 8. Okay? Okay. Okay, for scope, we have to change in here. Okay, because just for display, whatever. Okay, just set the PWM value, whatever. Okay, that one is for control the speed of the motor. We need a constant here. We need another constant here. We name it in here PWM value. And I just connect with this. Connect this one. Okay, connection is this variable. Okay, we can name it this one counterclockwise and or clockwise. Maybe in signal routing, you can find it manual switch or manual selector. Of course, you need the digital output in here. Okay. And you have to comparison, well, logic, okay. Compare to 0, compare to constant. Compare to I think we can use use both. But in here we can use compare to constant. Let's set the one. Just connect this one. Or you also need maybe display. Like that. Okay, display 1 in here, display 2 in here, whatever. This depends on your favor. You just investigate what is the value from this boolean when you change the value in here. Okay, I think everything is ready. We just set the digital pin. Set digital pin. Oh yeah, I curious this one, and there is no arrow in your version. Maybe I don't know. I can open the max here, but maybe in 2020 version, maybe this one is disappear. Maybe there are some lock. Maybe it's locking. Okay, no matter. Okay, I think everything is perfect in here. We just need to replace the this servo motor with DC motor. Okay, I will leave it this one. Very awkward. Wow, it's not respond anymore. I think the video is very heavy now. I think I have to cut this one. Okay, welcome back. We have to still replace this DC motor. Okay, let's see the response of this one. Okay, this one response or no response, I think. I don't know. I think this one is more faster. Okay, I replace this one for DC motor. This one I already connected. Okay, let's see what's happened. Oh, wait a minute, I want to change. Let's check the COM port. Oh, now it's COM3. We have to change this setting. Okay, change as COM3. Okay, I wish there is no problem in here. Let's check the main block diagram and delete this one. Okay, everything is remain the same, right? Counterclockwise 1, clockwise 0. Where is it? Okay, this one is same. You can see compared to constant is 1. Okay, I wish there is no problem. So we can run this simulation. Waiting, compiling, building. You can view diagnostics maybe. I wish there is no error in here. Okay, code generation report appears. Okay, basically we have this kind of post-fit modulation value is 0. Let's set the speed increase. Oh, the motor doesn't rotate. That is very interesting. I will check the connection. So here is the mistake. Which here is the mistake? Okay, now motor rotates. Okay, I have know the mistake in my program. I am just human. This one is problem. This one is not servo. Can you see this one is post with modulation of diagram block, but I use the servo diagram block. It's kind of make a problem. So we have to change this. Where is post with modulation? I do very stupid thing. You know, very basic problem. So set the post with modulation for pin 9. Okay, oh my god. Okay. How is now this working? Said this my video always go out. Don't know. The scope. Can you see it now? This DC motor and Arduino and this driver. And we can compile this one running simulation. And we set this one pulse width modulation will maximum. I wish there is no mistake for this experiment 6. I'm sorry for wasting your time and watching this lecture. Thank you for watching. Okay, so the generation appears and still connecting to Arduino Uno. And now see, motor is working perfectly. Can control the speed in here or lower, or this one is die. Stopping. I just set the pulse width modulation maybe around. Okay, this one is maximum. How much minimum pulse width modulation? This motor can rotate. Okay, this one still can rotate. This one still can rotate. Okay, around 60, it rotates very slowly. This one, and maybe because propeller. Okay, now can rotate again. I just set about 90. You can see this one, and you can change this one, the rotation direction. Okay, now change the value this one, and now it becomes 0. Okay, can you see it? Okay, change direction, right? Okay. Okay, my problem is because this diagram block I don't change it. Forgive me. That's previously is for servo. Okay. Okay. Only like this one. This one is our final experiment. So this one is stop. If you want to increase the pulse width modulation, can you see it? The graph also increase. Maybe around 100. The motor rotates under 3.3 volts maximum. I give in. Okay, this one is very low rotation. Can you see it? The camera capture the. Can I enlarge this video? Wow. Okay, very big. Okay, this one is graph, and we can control this one. Change the direction of speed, and this one stop because there doesn't have enough torque to rotate back. Okay, basically this one just control the rotation of direction. Clockwise, I correct this one clockwise. This one clockwise, right? This one counterclockwise, right? This one correct. This counterclockwise. Can you see the blade is rotate counterclockwise? This one, and this one change the speed. This one is maximum speed. Can change it. The direction. Change direction. Change direction. How many times you want. This is a Simulink model for DC motor control. Okay. Previously I do mistake for this diagram block, and here I don't change it for pulse width modulation. I do mistake in this part. I'm sorry for video is cut maybe. Okay. Okay, that's it. Just like that, control DC motor. Either change the speed or direction. That's the DC motor. This one is our final experiment for our lecture. This one is main diagram block. Remember, this one is pulse width modulation. I totally forgot this one. Okay, that's my mistake. Very basic mistake. And set this one run tiger. Okay, I think you understand this one. And this one, our last video in this lecture. How to run this video? Okay. Can see the pulse width modulation. We slide this. We start rotates motor. Okay, we can change the direction in here as we already done. Change direction. Okay. Click change again. Very simple, right? Just increase the speed of the pulse width modulation value. Okay. Okay. Very easy, right? Using Simulink. I wish you can understand how to operate DC motor control using MATLAB Simulink. Okay. Okay, that is our final presentation. And forgive me for some mistakes. Maybe I forgot some things. So thank you for your attention and have a good day. And I wish we meet again, or you have good grades. I wish you have good grades for my class, and thank you for watching this online lecture, and have a good day.